Hello! In this video, we're diving deep into the most important parts of the Anchor framework. Account types. On Solana, everything revolves around accounts. They store data, authority, and soul. Programs themselves are stateless. All logic and state live in accounts, and understanding how to work with them is key to building secure, efficient programs. Anchor, the most popular Rust framework for Solana, makes it easier. It introduces specialized account types that bring structure, safety, and clarity to our code. We'll break down what Derive Accounts macro really does under the hood, how Anchor uses it to validate ownership, enforce runtime constraints, deserialize accounts into usable Rust structs, and enable Solana's parallel transaction execution. You'll learn what each Anchor account type does, when to use it, and what trade-offs to consider. Understanding account types is critical, and by the end of this video, you'll have a clear mental model of how they work and why they matter. Let's talk about the account types in Anchor one by one, starting with account. This is your go-to account type for reading or mutating program-owned state. It validates that the account is owned by your program and deserializes it into a custom Rust struct T. Here's what these actions look like in the source code. Use it when you need structured data like user profiles or game state in program-owned accounts. AccountInfo type gives you raw access to the Solana account data. No validation, no deserialization, no safety checks. So use it only when you're manually validating or calling external programs. As a rule, the comment check for the documentation explains what kind of check and how it is performed. We see this warning in the source code. AccountInfo can be used as a type, but UncheckedAccount should be used instead. Because AccountInfo gives no guarantees about ownership, initialization, data structure, it's used when you need to handle raw accounts manually. Anchor can check anything for you, so bugs or vulnerabilities can easily slip in. UncheckedAccount provides some ergonomics while still being type-safe and auditable within Anchor. We'll also talk about UncheckedAccount type later in the video. Used only when you need full control, like manually verifying ownership or initialization, calling external programs via CPI, and working around Anchor constraints. AccountLoader type is for zero-copy deserialization, loading large data directly from memory. And its unique feature is that it avoids the usual BOSH or Anchor deserialize mechanisms, instead mapping memory directly using bytemark. This is more efficient for large accounts or those read or written often. To have a better idea how AccountLoader works, we go to the source code and see how here it ensures the account has the correct program owner, verifies the discriminator, returns the wrapped account loader. Skips the discriminator check, useful during init before it's written. Unique feature is that Anchor normally auto-writes discriminators, but here you handle them manually. These integrate AccountLoader into the broader Anchor framework and allows Anchor to construct it from the input AccountInfo. Here, pulls one AccountInfo, checks it, wraps it in a loader. I have to warn you that ref cell panics must be managed. Only use load init method once Just after AccountInit macro, it ensures discriminator is zeroed. Anchor's zero-copy loader, ideal for large accounts where performance matters, and frequent reads and writes without relocation. Useful for large leaderboards, game maps, order books, high-frequency data access. Just a reminder, Struct must implement zero-copy plus owner traits. You handle the discriminator manually, and be careful with ref cell borrows to avoid panics. Use it when you need performance and work with large data. Box of account. Solana has very tight stack limits, approximately 2.5 kilobytes. If you're passing many accounts or deeply nested data structures, you risk stack overflow. Use box account to move the account data from the stack to the heap. This type behaves just like account type, but stored on the heap. Use box to avoid stack overflows. When your instruction uses many accounts, it moves the account to the heap, preserving the same behavior as account. Interface is a lightweight wrapper of a program that semantically means this account implements a known interface, like token or token 2022. Interface is a lightweight or transparent wrapper of a program, giving it a clearer semantic meaning. This account implements some interface. T must implement checked ID, a trait used to restrict valid program IDs. This ensures two things. The account info matches a known ID via checkID method, and the account is executable. If either check fails, your program will error a runtime with an appropriate anchor error. Use it when you need flexibility with external programs, when your code must support multiple versions of a program, like if you want CPI compatibility with multiple implementations of a standard interface, for example SPL tokens. And you don't care about deserializing any program state. InterfaceAccount. It's similar to interface we've just talked about, but for accounts like mints or token accounts owned by specific programs. The difference with interface is that it validates program ownership, while InterfaceAccount validates data account ownership by an interface-compliant program like Mint or token account. InterfaceAccount is a generic wrapper around account type that verifies that the account's owner is allowed, deserializes the account data into a Rust struct T, enables use of foreign program accounts in your anchor program with type safety. Its key features that InterfaceAccount allows accessing accounts owned by other programs as long as their data can be deserialized and their owner is T owners, supports anchor and non-anchor data types, and prevents working with uninitialized system accounts. Let's take a look at the owner check logic of InterfaceAccount. It does this owner check. This is different from account type, which always requires info owner equals create ID. This means InterfaceAccount supports cross-program deserialization safely as long as the data type T provides a list of valid owners. Contains account under the hood and stores the owner to detect if ownership changes unexpectedly across the program. This can be useful for handling SPL tokens, accounts, or mints. Use it when you want to read external program data with type safety, or you want to allow any one of multiple token programs. Like you need to verify the account's owner is one of several allowed program IDs. You don't want to enforce a single strict owner like account does with the current program ID. I have to warn you that this type does not validate that the account is the correct type, only deserializes it if you call try from unchecked method. If used on a writable account, be careful not to write incorrectly to another program state. Owners must be correct, no fallback or fallback check. Option account. It's a way to make accounts optional in Anchor, using Rust's option of T, meaning it makes an account optional, allowing it to be none. In this example, it means that optional account may or may not be present in the transactions AccountInfo array. Looking at the source code, we see the core deserialization logic. If the account list is empty and the feature flag allow missing optionals is enabled, it returns OK, none. Otherwise, it fails with account not enough keys error. Delegates to AccountInfos to the wrapped value if it exists. If the value is none, returns an empty vector. This panics at runtime if toAccountMetas is called on none. It assumes that if you're compiling an instruction, the optional account is present. This is intentionally strict because you shouldn't try to generate instruction metadata for an account that won't be provided. If some attempts to close it, if none, does nothing, returns OK. Use the option account type when you want your program to support flexible instructions that behave differently based on presence of an account. 2 moments I'd like to emphasize on. toAccountMetas method will panic if called on none. And CPI clients must handle the optional logic when constructing the instruction. Program type. It is a validated reference to a specific program account, like system, token, or your own upgradable program. This lets you convert an account info into a program validating account key is equal to the hard-coded program ID and the account is executable. This is useful for verifying external programs like token programs, system programs, etc. in CPI scenarios. And there's an example usage from the documentation where program validates it's your own upgradable anchor program. Program data address method returns the program data account. Upgrade authority address ensures the upgrade signer matches. Upgrade authority logic is only valid for programs managed by BPF Loader Upgradable. Use this type when you need to validate a program's identity, you're performing a CPI, or you're checking for upgradability. The Sign It Up guarantees one thing. The account signed the transaction. It doesn't check account ownership, deserialize any data, or guarantee a specific account type. That makes it perfect for situations where you only care about signature authorization, such as verifying a user's approval for a transfer or checking upgrade authority. At runtime, Anchor ensures info is signer equals true. If the account didn't sign the transaction, the program throws account not signer error. In this example, the signer is only checked for the presence of a valid signature, nothing else. And in this case, payer just needs to sign. We don't need to know what data it holds or who owns it. Use it when you're verifying authority or user consent, accepting a payer, or validating multi-sig participant approval. So when you require proof that an account authorized the transaction and you don't care about the contents of ownership of that account. SystemAccount anchor type verifies that an account is owned by the system program and nothing else, meaning it doesn't deserialize any data, check whether it signed the transaction, or verify that it's initialized. In the source code, we see that basic constructor wraps an account info And here try from validates that the account is system owned and returns error otherwise. Talking about the use cases, SystemAccount is often used when working with system-owned accounts, accepting user wallets as payers or recipients of sold transfers, new account creation, and creating new accounts via CPI with the system program. Sysvar type is used to read Solana's built-in system variables like clock, rent, epoch schedule, and others. It verifies the account is a valid Sysvar of type T, deserializes it into a usable Rust struct, and provides economic access via deref. It doesn't require the account to be a signer or validate ownership, as it's implicitly owned by Sysvar address. It holds the raw account info, the deserialized Sysvar data of type T. This makes Sysvar a generic wrapper around the valid Sysvar type. Here it calls for validation, returns an error if the data doesn't match the expected Sysvar layout. Unlike user accounts, Sysvars don't need Anchor-style deserialization or ownership validation, and always emits a read-only account meta. Sysvars are never signers and never writable in normal use. An example of clock syscall and use of other Anchor account types you can check in the previous video. Use it when you are reading blockchain state like time or rent, when passing the Sysvar via account list like in CPIs or for clarity auditing, and prefer get method syscall when you don't need the account passed. Unchecked account is the most flexible and the most dangerous account type. It performs zero validation, no ownership, no layout, no signer, no deserialization. It exists to make this lack of checks explicit to the developer and auditor. This type wraps an account info without performing any validation. Use it with caution. This is an unsafe escape hatch meant for advanced or low-level use cases. Let's take a closer look at the source code. A tuple struct holding a reference to a single account. This is essentially a lightweight wrapper over raw account info. Returns the wrapper without any checks. This makes clear that the name try from is semantic only. It's always successful. Used in the block, marked with derive accounts macro. When Anchor is building the context struct, it pulls the next account from the array, wraps it in unchecked account with no validation. If the account list is empty, it fails with account not enough keys. Used when Anchor builds a transaction. It emits account meta new read-only or account meta new, depending on the is writable flag in the original account. Signer status is inferred from is signer or overridden. No ownership info is checked or encoded. These allow you to treat unchecked account as a plain account info. It's also documented with a check comment. In this case, you're fully responsible for safety, which is great for advanced use cases like CPIs or introspection. Use cases are low-level operations like CPA, PDA introspection, manual validation of accounts, multi-sig wallet logic or custom authority models. In other words, when you need flexibility, full control, and handle checks yourself. A recommendation: to prefer using a safer account type like account, program, or system account unless you explicitly need the lack of checks. Document why you're using unchecked account to help future auditors or teammates. Let's take a look at the AccountInfo type summary table that might be a cheat sheet for you. It contains some account types, common features, use cases, pros and cons. That's it! You now have a complete overview of every Anchor account type, from the most commonly used like Account and Signer to advanced tools like UncheckedAccount and InterfaceAccount. Understanding these types helps you write safer, more efficient and more auditable Solana programs. If this helped, don't forget to like, subscribe and check out my other videos on Solana program development. Thanks for watching. Bye!